All right, what's up, everybody? It's your boy, Professor Hustlenomics, aka the Math Philosopher, aka Javi. We're gonna get started today with a trigonometric identity. This is actually a part of Calculus 2. If any of you guys are going for engineering or any type of STEM, this will help you out in your courses. Please let me know, subscribe, and hit a like. Let's get started. So we have the integral of tangent of x raised to the 6th power. So the first thing we got to do is got to split it up. We're gonna have tangent to the 4th of x and tangent squared of x dx. So now once we split it up, we're going to use the trigonometric identity that tells me that tangent, we're going to put right here in the red, that tells me tangent squared of x is equal to secant squared of x minus 1. We're going to use that trigonometric identity, and we're going to go ahead and plug in for this guy right here. So we have tangent 4th of x and secant squared of x minus 1 dx. So now once we have that, we're going to distribute secant squared of x minus 1, and then we'll get tangent to the 4th of x, secant squared of x minus tangent 4th of x dx. Now once we have distributed, we're going to split up this guy right here that has the 4th, so we just have to rewrite this. A lot of the further and further you get, in your courses, you're going to realize that a lot of this is just rewriting the problem over and over again. Now I'm going to try to make this as fast as I can for you guys because it is a very long integral, so I will be skipping some steps. But nevertheless, we're going to keep going. The integral of tangent to the 4th of x and secant squared of x minus, now we're going to separate the integrals and we're going to put a parenthesis, because whenever you have a minus, it's going to distribute to each and every single one of the products that are inside, or the argument. It's going to distribute to each and one of the arguments that's inside the parentheses. And so once we have that, we're gonna use that same identity that we just used, and we're gonna replace that for that, and we're gonna do the same thing, and we're gonna distribute. So we have secant squared of x minus 1 times tangent squared of x dx. That's going to be inside the parentheses. And now we're going to distribute the same thing that we did up here. We're going to repeat the process. I know it's a long integral, but bear with me, guys. So it's going to be minus the integral of secant squared of x, tangent squared of x, minus tangent squared of x dx. Now, once we have that, we're going to split up this integral as well, and we're going to use the trigonometric identity one more time. So we have the integral of tangent to the 4th of x, secant squared of x, minus, inside the parentheses, we have the integral of secant squared of x, tangent squared of x dx, minus the integral of secant squared of x minus 1 dx. And that is the identity that we will constantly be using. Depending on the trigonometric function given, you will have to see which trigonometric identity is the one that you will have to use. I know it's a lot of repeating and a lot of writing it down, but this is what you have to do. You have to suffer and you have to endure this pain. You must master the monotonous. Okay, so now we're going to use u substitution. We're going to let u. You can really let any letter, doesn't have to be A, B, C, D, E, F, G, doesn't matter, Z including. I personally like to use U. We're going to let U equal tangent of x, and du will be secant squared of x. Now you should have your derivatives in mind, because if you don't, then we will have a hard time integrating. Now we're going to repeat this process again. Now we cannot let U be two things, so we're going to use Z equals tangent of x, and then dz is going to equal secant squared of x dx. Now you might be confused and saying, wait, which one are we substituting for? What are we doing? Well, this is what we're doing. We're going to integrate, and now we're going to plug in tangent for u. So now we have u to the 4th And what is du? Secant squared of x dx, which is what we have right here. Oh, I am so sorry. I forgot the dx. Let me just fix that really quick. Okay. And that is what we have right here. Secant squared of x dx. That is what we have. Secant squared of x dx. That will be du minus, do not forget the bracket. Very important to distribute that negative. The integral of, what did we let z equal? Tangent of x. So we have z squared. And then what do we have right here? Secant squared of x dx, which is secant squared of x dx is dz. Now we have the integral in terms of z, and we have another integral in terms of u. Minus, now with this integral, we can go ahead and split it up. Now, since we're splitting it up, we're going to have to use another bracket. Now we have the integral of secant squared of x dx minus the integral of 1, which is super easy. Now, do not forget the brackets. Like I said, very important here. Very, very important. Now, as you might know, the derivative of tangent is secant squared, and so in the integral, you will have a function that has been derived, so the antiderivative of, or in other words, the integral of secant squared of x will be tangent of x. So now, integrating, we have 1/5, u to the fifth, minus 1/3, z to the third. Ooh, that's a horrible 3, hold on. Minus tangent of x minus x plus c. Because it is a indefinite integral, we must always tack on that c. And so substituting for u, we know that u is tangent, so we have tangent 5th of x minus 1/3 tangent cube of x minus tangent of x minus x. And now distributing the negative, the negative is going to distribute and distribute. So if we distribute what's inside the parentheses first, we shall have a 1/3 tangent cubed of x minus tangent of x plus c. And then we have a 1/5 tangent to the 5th of x minus. And now we must distribute that negative everywhere that we see fit. And so the final answer will be 1/5 tangent 5th of x minus 1/3 tangent cubed of x plus tangent of x, because negative, negative, positive, negative, positive, negative, minus x plus c. And that, guys, is the final answer. Thank you so much for watching. Please subscribe, like, and comment. If you have any questions, let me know. Professor Hustle-nomics on the way out.